What if I told you that manually assigning IP addresses is costing you hours of work every week? Imagine a world where devices configure themselves automatically. No typos, no conflicts, just flawless network connectivity. In this video, I'll show you how DHCP and DNS work together to automate your network. Plus, reveal the simple Cisco router commands that will save you countless headaches. Stick around to the end where I'll show you the #1 mistake people make when setting up DHCP pools. DHCP and DNS. It is quite possible to assign IP addresses to network hosts on small networks, but on large networks, it can be a real burden for IT support. A DHCP server simplifies the assignment of IP addresses, and even on small networks, where there is a lot of travel, it will always be more pleasant to use a DHCP server. Also, unlike us humans, DHCP will not make any or very few mistakes at all. It helps provide very simplified administration when LANs are divided by VLANs, as it automatically assigns IP addresses to hosts based on their VLAN assignments. IP distribution is based on a client-server mode. On this topology, we will see how the PC, which carries the role of client, will get its IP address from the DHCP server. First, the PC sends a broadcast with its own MAC address to see if there are DHCP servers around. Then, when a DHCP server receives this type of message from a client, it automatically reserves an IP for it and responds with a message such as DHCP offer. In this message, there is the MAC address of the client, the IP address that the server offers him, the subnet mask, the duration of the rental, and the IP of the DHCP server that makes this irresistible offer. When the PC receives it, it responds with a message such as DHCP request to indicate to the server that it intends to accept the parameters of this incredible offer. The DHCP request will still be broadcast because the PC still hasn't applied the settings. And finally, the DHCP server will send a unicast acknowledgement to the PC to confirm all the proposed parameters. In the capture of packets on DHCP requests, we can clearly see all the steps on the assignment of an IP address by the DHCP server. Now, we're going to move on to setting up a Cisco DHCP router. We want LAN users to receive an IP address from the pool in 192.768.1.0/24 with a rental period of up to 12 hours. Addresses from point 1 to 100 will have to be excluded from this DHCP pool, and at the same time, you will take advantage of this to add the DNS settings, the domain name, and the default gateway. The first command in global configuration mode allows you to specify an IP range that you want to exclude from DHCP. IP DHCP pool allows you to define the name of the DHCP pool while entering its configuration mode. We can see here that the acronym has become DHCP config. The network command allows you to define the entire network of the pool. Here it is. The 192.168.1.0/24 network. That is to say, addresses from point 1 to point 254, excluding those that have been excluded. The point 0 is the network address, and the 255 is the broadcast address. The DHCP knows very well that it cannot touch these two addresses. The default router command is used to specify the default gateway for PCs. Here, it will simply be our router. DNS-server is to specify the address of the DNS server, domain name for the domain name of the DHCP server, and the lease command specifies the rental period of the address. 012 means 0 days and 12 hours. Ending with an exit allows you to return to global configuration mode. It does not validate commands. The configuration is systematically validated with each command entered. Now, let's talk about DNS. DNS converts human-readable names into IP addresses that machines use for routing. When we surf the web, it is difficult for us to remember the IPs of all the sites we want to consult. That's why domain names were created to convert the numeric address into a name, which is much easier to remember. The DNS protocol uses a set of servers to translate names into IP addresses. In this part, we'll look at how to configure a Cisco router as a DHCP server. Here, the router on the left will be the client, and the one on the right will be our DHCP server. To begin with, we will assign the IP 192.168.10.254 with a mask in 3x2.5.0 on the 00 interface of the DHCP router. Then, we will create a DHCP pool, which we will name Pool 1, with the command IP DHCP pool. The network command tells the router for which network we want to distribute the IP addresses. You can add a default gateway for clients with the default router command, and also a DNS server with the dns-server command. In this example, client will receive in more of their IP the gateway which corresponds to the 00 leg of the DHCP and the DNS config from Google. You can also exclude addresses that you would not want to distribute to the client. In this example, we exclude IPs from 100 to 200, so be careful. This command is to be entered in global configuration mode and not in our DHCP pool. And now, we still have more to tell our client router to be assigned an IP by DHCP with the command IP address DHCP. Immediately, you can see in the console that the DHCP has assigned it the address 192.168.10.1. And finally, it is possible to see the list of all DHCP leases with the command show IP DHCP binding.